Hello, everyone. We began our discussion of statistical process control with X-bar and R charts for continuous data. And we continued to look at P and C charts for attribute data. We then introduced the charts for slow-moving data, including X charts for individuals, moving average, and moving range charts. And we mentioned the exponentially weighted moving average chart, or EWMA. But now, in this session, we'd like to introduce a few more control charts so that you're aware of them. And again, you're not going to be responsible for any control limit calculations for these particular charts, but we want you to know that other charts exist and are commonly used, and when they should be applied in Six Sigma. So in particular, we would like you to become familiar with the S chart, the standard deviation chart. We want you to understand when you'd use P charts with varying sample sizes, the NP and the 100P charts, and finally U charts, and when all of these charts should be used. Now, we talked about the R chart, the range chart, being commonly used to control process variability, partly because of the simplicity of computing the range of a sample. However, in some situations, an S chart, or the standard deviation chart, is preferred. For example, an S chart is preferred when the sample size becomes large, for example, greater than 10. Now, why would you do this? You might need extra sensitivity for your X chart for controlling the process mean. So then you would increase your sample size, but then you have the problem that the R chart, the statistic R, becomes very sensitive to the larger variability with the larger sample sizes. Another point is the R chart was often used because it was simple to calculate. But today we have the implementation of SPC tools on computers, and this simplicity is really not an advantage any longer. So in these cases, you can use the S chart in place of your R chart to accompany your X-bar chart. For the S chart, instead of calculating a sample range, you'll be calculating the sample standard deviation, the same way we've always done this. The X-bar chart keeps, of course, the same upper and lower control limits as before, and you would have then upper and lower control limits for your S chart, this time using the constants, the standard constants that you would get from a table, to give you again the 3 sigma control limits, but this time for your statistic S. The method of constructing and interpreting these charts, though, are exactly the same as we've done for the X and the X-bar and the R chart combination. And we'd like to look again at the example we had before, measuring the net weight of a chemical in a filled bag. This was used to control the filling operation, and we were interested in looking at the average and the variability of the weight of the filled bags. We wanted that to remain consistent, so we decided to implement SPC. And we did it at the time using X-bar and R charts, and now we'd like to see what this looks like with a standard deviation chart. Now again, we had 24 samples, and it looked like this, if you remember. 24 samples were taken periodically. We had here n equals 5 for each of those samples, and we used these 24 samples then to calculate upper control limit and lower control limit for X-bar, and upper control limit and lower control limit for the range. And what we noticed was everything for the X-bar chart was in control, but sample 22 here was, sample number 22 was just above the upper control limit for the range. So the range had number 22, the range chart had number 22 out of control. And if you remember, we then looked for the assignable cause, and we eliminated that particular point, and we recalculated our upper and lower control limits using the rest of the data. Now, what we want to do here is to look at these charts from the same data, including sample 22, with the X-bar and S charts. And it'll look a little different because it's done on Minitab, but here we're calculating the X-bar and the S charts using the same data. So the X-bar chart looks the same. We have the same upper and lower control limits, and everything is in control for the X-bar. For the sample standard deviation, the S chart, what you notice here, well, first of all, upper and lower control limits are different. We're using different formulas for that, but they represent the 3 sigma limits. And here, sample 22, it's borderline, right? It's actually in control, very, very close to the limit in the S chart. And so you would actually also say here that on our 24 samples, including sample 22, our S chart is also in control. Now, in practice, you might look at that. This is the first time you've done it. Maybe you might look again at that point. But what we know is that the statistic S is a better estimator of the process variability than the statistic R. So we should believe these charts, and we would say then that we could go ahead and use all the data and use these control limits then to continue our monitoring. Maybe if we're worried, we would then take some more data later and see if we can refine those control limits a little bit better.